Welcome to this crash course on ASP.NET Core, MVC, and Entity Framework Core in .NET 9. This is a step-by-step tutorial covering the essential topics and foundational knowledge needed to start learning ASP.NET Core MVC from scratch. Prolific creator Alan Omari created this course.
If you want to learn ASP.NET Core MVC from the ground up, this course will take you there. We'll start by breaking down the entire MVC app structure, exploring every file, covering the main concepts you need to know, and then dive into working with databases using Entity Framework Core, from CRUD operations to complex database relationships. We will be using the latest .NET version, .NET 9, and it's going to be super simple. Well, welcome to Code the Future. My name is Alan, and I help you learn C# and .NET on your own. Now let's get into it. I'm going to explain to you what the MVC architecture is in programming, and I'm going to walk you through everything you need to know. MVC stands for Model View Controller, and it is an architectural pattern that divides an application into three primary components: models, views, and controllers. This separation helps achieve a clear division of concerns in our applications. Separating concerns or responsibilities in MVC makes the application easier to develop, debug, and test because each part, either the model, the view, or the controller, has a specific job. When responsibilities are mixed, like combining user interface and business logic, changes to one can affect the other, making updates and testing harder and more error-prone. For example, user interface logic changes often, so if it's combined with business logic, you'd need to modify and retest both every time the interface changes. Now let's see each of these components in more detail. The model in MVC represents the information or the data the application operates on, and handles the logic for processing this data. For example, if you have an application for managing books in a library, the model would represent the data about the books and the rules for adding, updating, or removing books from the collection. A view in MVC is the part of the application that displays the data to the user. A controller then manages user input and interaction, determining which model types to work with and which view to render, effectively controlling the application's response to requests. I'm going to show you how to download and install .NET 9 and the latest version of Visual Studio, which is our IDE, in order to be able to work in .NET 9. So let's get into it. So I'm just going to click on Google, download .NET 9, and we'll see the first thing we have here in the Microsoft's website. We should be redirected to the page that allows us to install the .NET 9 SDK. In the time of recording this tutorial, we have the 5th preview of .NET 9. Probably when you will see this, it will be fully out, the final .NET 9 version, but this is what we'll use, and there shouldn't be many changes with the final version. So here we have .NET 9 preview 5. Depending on your operating system, here just choose the correct one for you. I am using Windows and my processor is a 64 processor. I'll select this option right here and we'll wait for .NET 9 SDK to be installed. So it is already installed. Let me click on it. Click on install here. Okay, the installation was successful. Let me close this window here, and now if we just go back to the page we previously were, we can actually check what we can go here to .NET Preview 5 to release notes to see what version of Visual Studio .NET 9 actually requires. If we scroll a bit below, we will see that .NET 9 is compatible with Visual Studio 17.11 latest preview, and if I click on it, can basically download the latest version here in this part by just going to Community 22 to download the free version. And the downloads start right here, but I actually have the Visual Studio installed and I could have just updated it on my application, but let's see how it works right here. If I click on it, I should receive the option to actually just upgrade. Continue. Now the Visual Studio installer is opened and it gives us the option to update to the latest version. I'm just going to click on update and the download starts. We'll give it a bit of time. Now, after a while, the Visual Studio's latest version is already installed, as you can see here. So we have the latest version of .NET, the latest version of Visual Studio, and we are ready to go. Now, one last thing you want to do if you are using a preview version like myself is actually going to need to go to the settings to Visual Studio to allow these previews. So let me open up Visual Studio. Click on continue without code, so I don't need to open a specific project. Go to tools. Go to manage preview features. And a bit below, we should see an option here. We should click on this option here, use previews of the .NET SDK. This enables the ability, as we can see here, to consume preview SDKs by default. If I click on it, click OK. If we restart the Visual Studio, then we should be able to work with the preview version of .NET 9. You need to know the contents of each file in your project when building anything in programming. For this reason, I'm going to explain to you concisely the role of all files you have when you create an MVC web application project in ASP.NET Core. To create our first application, we can just open Visual Studio and click on Create a new project. Next, find an MVC template for a web application and make sure that C# is the language for this template, not F#, for example. In the page that loads, give a name to your app, like My App. You can change the location where you want your project to be stored if you want as well. Click on Next, and here I will select the .NET version to be .NET 9, this preview version, but the final release of .NET 9 may be available by the time you watch this tutorial. Let's leave all the other settings as they are for now and just click on Create. Here we have our application. When you create a new ASP.NET Core MVC project, several key files and folders are automatically generated. Let's go through them one by one. First, we have the program.cs file. This is the entry point for the application. This first line initializes a new instance of the Web Application Builder class, which sets up the configuration, services, and the web server. Next, we add services to the dependency injection container. Here we are adding MVC services to the container with support for both controllers and views. This allows our application to handle incoming HTTP requests and render HTML views. Then we build the application. This line compiles the app, creating a web application instance, which you can then configure and run. Now we configure the HTTP request pipeline, which determines how requests are processed by the app. If the app is not in the development environment, we set up an exception handler to redirect users to the home/error page when an unhandled exception occurs. Additionally, we enable HTTP strict transport security to enforce secure HTTPS connections. We continue configuring the pipeline with this app.use HTTPS redirection, which ensures that HTTP requests are redirected to HTTPS, and app.useRouting enables routing, which allows the app to match incoming requests to the appropriate endpoint. Next, we have the app.useAuthorization, which is responsible for authorizing users to access secured resources. We map then static assets. This line enables serving static files such as images, CSS, and JavaScript from the www.root folder. Then we configure the default route for the MVC application here. This sets up the default route pattern, which maps to the home controller and its index action method by default. The ID parameter is optional. So this is the default route that will be redirected to when we start our application. Every URL is actually assumed to have this pattern. The first part is the controller, then a method of that controller, which is actually called an action in ASP.NET Core, and the ID that is optional. Let's say a request is made to a URL called /items/overview. Our application will try to call an action called overview inside an items controller. And now let's go to the last line. Finally, we run the application. This line starts the web application and begins listening for HTTP requests. Now, let us now see what the other folders do as well. Just as a reminder, if you want to get the fundamentals right while learning C#, you should check out my ebook, which is on sale now. It will help you with whatever you're building in .NET and save you hours of research by providing all the C# insights you need in one place. This book will be a valuable resource for everything C# related, and you can find the link in the description if you want to check it out. Now back to the video. The controllers folder contains the controller classes. These handle incoming HTTP requests, process user input, and interact with the model to return the appropriate view. For example, we have the home controller here that is already created. The models folder then contains classes that represent the data of the application. Here we have a sample model, errorViewModel.cs, which is used for error handling. The views folder contains the eraser view files, or the .cshtml files, used to render HTML to the client. In this folder, you'll also find the view imports.cshtml, which contains directives that are imported into every view, such as tag helpers, and the underline view start.cshtml, which specifies common view configurations like the layout. Within the views folder, there's also a shared subfolder, which contains shared views like the layout, which is the layout page that is used as a default design for all pages, and this underline validation scripts partial.cshtml file, which contains client-side validation scripts. There's also a home folder, which contains views related to the home controller, such as the index, view page, and the privacy view page. The www.root folder is the root for the application's static files like CSS, JavaScript, images, and other assets. Inside, you'll find subfolders like CSS for style sheets and JavaScript for JavaScript files. For example, site.css and site.js are default files included for your custom styles and scripts. Next, we have the configuration files. The app-settings.json file is the main configuration file for the application. It contains settings like connection strings and app-specific configurations, which we'll see later on. Let's take a look at the properties folder as well, where we have the launch-settings.json file that contains settings related to how the application is launched during development. They can be modified to suit the specific requirements of the project or different development environments. And that's a quick overview of the main files and folders in an ASP.NET Core MVC web application project. I'm going to show you the basics of ASP.NET Core MVC using .NET 9. We will see how to work with the models, the controllers, and the views, and how they interact with each other, all in this short video. If you're new to MVC, this is the perfect starting point. I'm just going to go to the models folder and create a new model, or basically a new class for the models. I'll name it, let's say, item.cs. We'll see that a simple class will be created. Now, this class represents the data of our application. If we were to store this, which we'll do later on, in a database, this class that's stored in the models folder will represent a table in our database. And each property that this class will take will represent the different columns that the table will contain. So we can give to this class different properties. Let's say, let me just give it an ID property firstly, and I'll explain everything. So basically, we're setting an access modifier to public for this property so that it can be accessed outside the class. The ID, we name the property here, and it will be an integer. This is the type of data. And here we have a getter and a setter that allows this property to be accessed outside of our class. So this is an auto-implemented property. This is just some C# theory here. We can specify here different properties for our model, and we gave each item an ID. We can give also each item a name. I'll set it to be public string. The name will have the data type of string. I'll name it name, and the getter and setter as well. Now let's say we want to access this item in a specific URL pattern. Let's say that it would be /items/ let's say overview. So we'll create this application so that when a user makes a request to this URL, it will be redirected to a page that gives him the item. For this reason, what we're going to need is we're going to need a controller named items and also an action in that controller named overview. Let me just go to the controllers folder and add a new controller. I select an empty template here, click on add. I'll name the controller to be items controller. And we'll see a simple class here, an items controller, the items controller class, which inherits from a base controller class. Basically, every controller will inherit this base controller class because it inherits multiple methods, but you do not need to worry about this for now. We can see, as we talked before, each method in a controller is called action in ASP.NET Core MVC. And here we see this index method, or this index action here. This is a public method. It returns an IActionResult and it's named index. I'm gonna clarify to you in the next section what IActionResult means in more detail, but basically this just allows our method to return different types of things. In this case, we are returning a view, which is actually included in this IActionResult return type. But as I said, we'll talk about the action parameters and action result types in the next section. For now, what we'll do is that I'm gonna actually change the name of this action to be overview, since we wanted the user to be redirected to this specific route. And I'm going to take an instance. I'm going to create an instance of the model that we just created here inside this action. Taking a variable, naming it item equals to new item. And I'm going to need to import the model on top of the controller so that the controller knows the model basically that we created before. So I'm going to need to use this using directive, the name of the application, .models here. And as you can see, this item keyword is now in green because the page recognizes what it means. And let me just create one item here. It's not necessary for me to give an ID to the model because the program will give it itself. So I'm just going to specify for the item the name property. And let's give a name to a random item. Let's say keyboard. And that's it. So I have created an item here and I'm going to pass it actually to the view so that we can be able to render this item that I created here inside the view that we'll basically need to create. What this action here does is that it creates the item, it renders the view, but we're going to need to create the view because we don't have a view named overview yet. We can just go to the views folder. We're going to need to actually create a folder to store all of the views inside the items controller. For this reason, I'm going to name it items. And inside this items folder, we can store views for each action in this controller. And for our case, I'm creating an empty view and I'm naming it according to the name of the action, which was overview. And here we have our overview CS.html page. Here we can write the plain HTML code that will be rendered to the user, but we can also embed here C# code, which we'll see in a bit, what we want to store in this page. I'm actually writing a HTML paragraph here, and I'm going to display to the user, this is the name of the item. And for me to actually access this item model that we created inside our controller here, that we put as a parameter in the view, I'm going to need to import the specific model on top of our view page. I'll do it by just writing this @ model and then the exact address of the model that we created, which is the name of the application, .models, the name of the model, item. And now I can access the item that we gave into the view by just writing this @. The @ we'll use a lot. This is how we basically write C# code inside our view pages. And for me to access the model, I need this model keyword and @model. And here I can access the ID or the name of our model. I'm going to access the name here in this case. And now if we run the project, let's see what we have written now. Now, this is our home controller, the index page, the default route of our application. So this is what we'll see here. But if we go to /items/overview, we will be redirected to the items controller, to the overview action, which will actually render our overview view page. Let me just hit enter, and we should see here, this is the name of the item, and then the name of the item, which we specified by using this C# code in our view page. So this is just the basics. It may seem a bit complex right now, but you have worked with models, controllers, and views all in this short video. I'm going to explain to you what IActionResult is in ASP.NET Core, why we use it, and I'm going to walk you through everything you need to know. In the previous section, we saw inside our controller that the actions return this IActionResult. But what is the IActionResult? IActionResult is an interface that basically defines a contract for all the different kinds of results that an action can return. Inside of an action, we can return to the user different results. We can return a page, we can redirect the user somewhere, we can return a JSON, just a simple message, and so on. All of these different action results derive from the IActionResult interface. In some cases, we may have a condition inside our action which would return different information to the user depending on specific requirements. And in this case, for us to include each of these different return types in the return type of the action, we specify here IActionResult instead of just specifying, let's say, view result or content result, so that it includes everything that the action can return. Let me just remove this and show you what we could use if we didn't use the IActionResult. If we would want to just return a view, let's say we can just return here a view result and then return the view here. Actually, the view that we are returning here is just a helper method that is inherited from the controller class, and it's just a shortage of this view result. The long way of writing it would be return new view result. But as I said, this is a helper method that allows us to write it in a more flexible and short way, and this is the way you will mostly see it in the code or from the documentation. So we could return different kinds. We could also return other kinds of information inside a action. We could return content result. And here I can just write return content. Content is as well a helper method. Here I can just write a message to the user like hello there. We can return just JSON result, a redirection result, and so on. But every of these different result types inherits from the IActionResult. And as I said, that's why we basically just write on top of as a return type of every action IActionResult, so everything is included in it. I'm going to explain to you what action parameters are in ASP.NET Core and the different kinds of them. I'm going to walk you through some examples as well so that you'll learn how they work. So let's get started. Action parameters are a way for our actions to receive input data. This input data can come from different sources such as URL segments, query strings, form submissions, or even a combination of some of these. Let's just start to see how the URL segment parameters work. In our items controller, I'm just going to create a new action. So public IActionResult. I'm actually going to name it edit. And here in this action, I'm going to receive an int ID parameter from the URL. And in this case, the parameter is passed to the action directly from the URL depending on the route configurations of our application. If you remember in program.cs, the default route pattern here is specified and it actually allows us to receive an ID parameter. Okay, so let's go back to the controller. And I'm just going to return on the screen some content. I'm going to write here return content, and I'm just going to return basically a message on the screen. So I will return the ID. Then I'm going to pass here the value that we get, or the parameter that we get from the URL. Let me just run our project. And if I go to this specific route to items, the name of the controller, /edit / let's say 231, whatever number you want, we'll see that the parameter is passed to the action from the URL directly, and then we have displayed this parameter on the screen. So we can see here that the ID is equal to 2. Now let's just see how the query string parameters work. So query string parameters are this part in the URL that comes after the question mark, and they are usually used to filter or to sort. This method is usually used to filter or to sort data actually. Let's just see here how it works. So after the edit part, we'll input here question mark and give the ID the value of, let's say, 4. Click on enter and we can see on the screen that the ID has the value of 4. So the parameter is passed from the query string to our action, and we see here the value of the ID on the screen. Now, another way would also be, as I told you before, to take data from form submissions, but do not have the necessary knowledge yet. So I'm just not going to take an example for it. And one last thing I wanted to mention is that if we would actually change the name of the parameter we take from our action here, let's say change it to item ID, we would be able to still get the data from the query string, but we would not be able to take this from the URL segment, just because in the program.cs file here in the pattern of our route, we have specified that we can take from the URL can take an ID parameter and not an items ID parameter, so to say. So if I just go back here, run the project, let's say if I go to the route here, items / edit, and I write this query string, item ID equals to 5, we should still see the value of the ID printed in the screen. But if I would do it using the URL segment, like edit /7, we would see that the value of the ID would default to 0, just because we are not taking the value from the URL in this case. Razor is a markup syntax used in ASP.NET Core to embed C# code into HTML. It's designed to be clean and concise, making your code easier to read and maintain. You'll commonly see Razor syntax in views, which are responsible for rendering the UI. Razor syntax is denoted by the @ symbol. Now let's look at some common uses. First, let's start with basic variable embedding. Suppose we have a variable that we want to display in our view. In this example, we declare a variable message inside this code block that we can write inside our view pages and use the @message syntax to embed its value inside a paragraph tag. Razor also supports embedding more complex expressions and C# code blocks. For instance, let's loop through a list of items and display each one of them. Here we use the @forEach loop to iterate over a list of items and output each item within a list tag. Notice how we seamlessly switch between C# and HTML. Razor syntax also includes conditional statements, which are useful for rendering different content based on certain conditions. Let's see an example with an if-else statement. Depending on the value of the isLoggedIn variable, Razor will render either welcome back or please log in. This makes our views dynamic and responsive to the application's state. Now let's talk about the Razor directives. Directives are special instructions for the Razor engine, and they're prefixed with the symbol. Some common directives include @page, @modal, and @using. For example, the @modal directive specifies the type of modal data the view expects. This is crucial for strongly typed views. In this example, the @modal directive is used to indicate that this view expects a myViewModal object. We can then access the modal's properties using @modal. Lastly, Razor has a feature called tag helpers, which allows us to dynamically add behaviors and attributes to HTML elements. Tag helpers make our Razor views cleaner and more maintainable. Here's a simple example using the ASP4 tag helper. The ASP4 tag helper binds the input field to the name property of the modal. This ensures that the correct value is posted back to the server when the form is submitted. So what is Entity Framework Core? Entity Framework Core is a toolset for .NET developers that simplifies database access by allowing us to work with databases using .NET objects. It eliminates the need to write complex SQL queries by providing a way to query and manipulate data using C# code. Entity Framework Core supports various database operations like creating, reading, updating, and deleting data, making it easier to manage database interactions in an object-oriented manner. There are two main approaches to using Entity Framework Core: the code-first approach and the database-first approach. In this video, we will learn how the code-first approach works. The code-first approach in Entity Framework Core allows us to define the database schema using C# classes and then generate the database from these classes. The database-first approach works the other way around. The code-first approach is ideal when starting a new project without an existing database, as it provides full control over the data model through code. Okay, so we're going to start with the code-first approach, and we're just inside our MVC web app template here. In Visual Studio, the first thing we're going to need to do is go to the dependencies here, click with the right of the mouse, and select Manage NuGet Packages. We're going to need to install the needed NuGet packages in order to implement Entity Framework Core inside our project. So the first package we need here is Entity Framework Core. The first one you see here, click on Install. Click on I accept. Next, we need the Microsoft Entity Framework Core tools. Click on Install as well. And then the Microsoft.Entity Framework Core.SQL Server, since we are connecting our project with a SQL Server database with SQL Server Management Studio, actually. Click on it and install. So all of these packages that we're installing right now have necessary tools and commands needed for us to basically map our C# classes and models and generate a database and connect it basically with the SQL Server database. Okay, now that we have all of our 3 packages installed, let's just check the models that we have in this project. So here I have only like a simple item model with an ID property and a name property. And we will store this model inside our database. What we're going to need other than our model, we're going to need a context class, which as a practice is stored inside the data folder. And I'm just going to explain to you what the context class is needed for, but let's just create the data folder firstly. Just add a folder called data. And inside the data folder, we're going to add a class. I'll name it my app context or something with context in it. Click on add. Now here we have our context class. We are going to need that our class inherits from the Entity Framework course DB context class. And let me see what we need to inherit here. We need actually to inherit Entity Framework core on top of the page, I would suggest. Using Entity Framework core on top of the page, and this class basically contains many properties and methods in order for the context to do its work. So the context is this class, like the main bridge that connects our project with the database. Here we store every instance of the models we have in our project, and with the context, with the method that the context provides, it's possible to basically query data from the database, filter them, get the data, or modify them. What we're going to need after inheriting the DB context class is we need a constructor inside our context class, and this will just contain a few generic parameters to enable the needed configurations for our context. So these are the parameters that our constructor needs to have. And what we also need to write here is, as I told you, we need inside the context, we store an instance for each model that we have in our project. In this case, we have this item model, and we need a dbset instance, which is this entity framework class, and this will be for our item model. We give it a name like items, and we give it this getter and setter. So this is written just like a property and enables us to access this model from the database, and basically what we have in our project to store it in the database. We need to import the models folder on top of the page, my app.models, and this is it for the context. The next step we need to take is to create a database instance in our SQL Server Management Studio that we're going to use as the database for our project. We can just go to the View menu here and click on Server Explorer. Here we have all of the basically a lot of database instances I had created before. We just need to go here to Data Connections, click with the right of the mouse, and click on Create New SQL Server Database. Here we need to write the server name, and basically if you open up the Microsoft SQL Server Management Studio, you will see the server name on top of the page. If we can just click the name of it here, connect the SQL Server Management Studio to our server, and go back to the project. Input the name here. We'll use the Windows authentication to log on to the server. The encryption will set to false. You click on Trust Certificate here. We're just selecting the authentication. This is a default one. We're selecting that we do not need to use a password to connect to our database. Basically here, just some options, just some configurations. Don't think too much about it. And give the database a name, like my app database. Click on OK, and after the database will be generated, we should see in this window right here the name of the connection string. The connection string is the address of the physical database. So basically this tells us where the database is located. We should copy this, and the connection string we need to input it in our app settings.json file so that we then can connect our project to this physical database. Here we need to write connection strings, and we need to give a name to the connection string. I usually name it like default connection string, it doesn't matter. Here we input what we took from we input the name of the connection string, just right here with the name of the server, the name of the database, as you can see here, and we put the encryption to false, and some other configurations. The last step now to connect our project to the database will just be to go to program.cs and add a service in the services containers. Basically, this will connect our database with our project and with our context. So I'll just add the service here, builder.services that add context. The name of our context was my app context. Here inside we'll just input a few options. Let me put this in a new line. Options does use SQL Server. And inside here we need to access that connection string to get the location of our database, builder.configuration.get connection string. And we need to input here the name of our connection string. Connection string. Just close the parenthesis here. So basically we are writing a service to connect our context basically with our database here. Just let me remove this dot here. We need to import entity framework on top. We need to add the migrations to our database. A migration is basically just a class that will be created that is the code, the representation of how our database will look like, with all of our configurations for our models and the context that we have already written here. So to do that, we're just going to need to go to Tools, Package Manager Console here, and just write the command add -migration and just give a name to the migration. Hit on enter. So build succeeded, and we should see this migration class here on the screen. A migrations folder will be basically created. The migrations track every change we do to the database schema, and each time we change the models or the context, we need to add a new migration to the database. You can see here that the table will be created on a database with a columns, an ID column, with its specifications and a name column here. The primary key is by default the ID property, as we can see here. And the last thing we need to do is to basically write the comment here, update database, and this migration will be added to our database. Right now, a table for our items should be generated already in our database. If you go to SQL Server Management Studio, to databases, let me find the right database of our project, which were my app database. You can click on tables. We have a table for the migrations here, Entity Framework Core migrations history, which basically tracks all the changes to the database schema that we make. And right below, we see the items table. If we click on edit top 200 rows, we should see basically an empty table, but the table with an ID and a name. We can click on design here to see our columns. So this is how Entity Framework Core's code-first approach works. In this video, we will learn how the database-first approach works. The database-first approach in Entity Framework Core involves generating C# classes and a DB context from an existing database schema. This method is suitable when working with a legacy database or when the database design is managed outside of the application development process, allowing us to integrate the existing database into the application seamlessly. I'm in SQL Server Management Studio here, and I have a database, and basically I have 3 tables here, 3 pre-populated tables, a dishes table here, an ingredients table, and a dish ingredients table. And I'm going to use this database to create the models and the context in a new project. So I have just created a new MVC web app project, and I have already installed Microsoft Entity Framework Core, Framework Core.SQL Server, and Microsoft.Entity Framework Core.Tools. So you need these 3 packages to be able to work with Entity Framework Core. And now what we will do is just go to Package Manager console here and write this command, scaffold -db context. Then here we need to input the connection string of the database that we will import. So I have already copied it. After this line, we need to write here Microsoft.Entity Framework Core.SQL Server. Then we need to write dash context directory data. So here we'll specify in which directory our context will be stored, which will be stored in a folder named data. And then output directory. Here we specify the directory of where the models will be stored. So they will be stored in the models folder. And I will specify here the data annotation flag. What data annotations are basically these attributes that each property in our models take to basically validate them, to specify the relationship with each other or how they will be stored in the database. And if we specify this flag here, when the models will be created, the data annotations will be included in them. So now if you just hit enter, we'll wait for the build to succeed. And the build succeeded. If we open up our models folder here, we'll see that in our models folder, we have the dish model. These are the data annotations that were included in our models. We have the ingredient model right here. And in our data folder, we have our data context. The dish ingredient helper model was not created as a separate model in our models folder, but the relationship between dish ingredient, dish, and ingredient models was specified in the DB context in the onModel creating method. It's a bit different from how we typically specify it, but it should achieve the same result. CRUD stands for Create, Read, Update, and Delete, and these are the basic operations included in every application. We will perform these operations on our data in this project and show the changes in the front end. We have already created a simple model and stored it in the database using the Entity Framework course Code First approach. This is the MVC project. We have only one model. We created a context and we stored these changes to the database. Now, one more thing I'm going to do before we start is that I'm going to add another property to our model just because it's a little too short, but we'll still keep it short so that you understand everything better, so that it is the most simple thing ever. So I'm just going to add another property, a double property named price for our item. We have already created migration and stored it in the database for our project. Now that we made a change to the model, we're going to need to add the migrations one more time to our database. For this reason, we just need to go to Package Manager console and click Add Migration and put a name here for the migration. Let's say second migration. Hit Enter. And basically this migration class that represents our database schema should be created, that should be displayed in the screen. And of course, add it in our migrations folder. So we'll just wait for the build to succeed. And this is the migration that we already created. So a new column was added to our database, to our table in the database for the price. And now just need to click on to write the command update database to perform these changes to our database as well. Build succeeded. So now we just need to go to our items controller, and this is where all of the actions that will perform the needed operations will be stored. I'm just going to delete these two actions we had created previously. And first of all, what we're going to need is, for us to access the database, we're going to need to import the context in our controller. Firstly, I'm just going to need a private read-only variable to basically store the context, and we'll use this variable to do all sorts of methods that we can use from our context. But right now, just let's create this variable. I'll name it with the name of the context here. So this variable will hold our context. I'll just name it underline context, just as a practice. And inside the constructor for our controller, here we'll take basically the context by writing the context here and a variable to represent it. And then in the private variable that we declared above, we are just going to need to add the value of the context to our context variable that we'll use in the controller right here. Add a new line here. After storing the context in this variable, now we'll start with writing each of the actions. The first action, it's going to be a public IActionResult. I'll name it index for the main page, which will basically just display all of the items that we'll take from the database. And here we're going to return a view, but we need to return a view with the items that we'll take using the context from the database. For this reason, I'm just going to take a variable, call it item, and I'm going to access this from the database by using the underline context variable dot items to access the instance of the item created in our database, in our context that we have here. And then we need to write a method to list all of these items, just like this. But in such a case, when we query data from the database, it's recommended, and it's always what we do, is that we make the method, the action method, to be asynchronous. An asynchronous action method basically allows us to await some data from the database, which means that the method will stop until we take all of the necessary data that we need and then continues where we left off. For this reason, to write an asynchronous action method, we need the async keyword here on the method, and then this method needs to return a task of IActionResult. And we need as well to write the await keyword in front of the part where we query the data from the database. And in a case like this, we need to use as well the toList async method, which lists these items asynchronously. We need to import entity framework core in order that it recognizes the toList async method. Entity framework core. Now we do not get an error here, so basically what we did here, our asynchronous action method allows us to wait until this task is fully performed, and then it continues to return the view, and the view should contain all of the data that we take here from the database. Now, after writing the index action method, we need to create the view page. To create a view page, let's just go to the items folder, which is the name of the controller. And here I'm going to create a new view page with the name of the action, index.cshtml. Let's remove this part here. Now, in this view page, we use Razor syntax to basically embed the C# code in our views as well. And on top of the page, because in this page, we are going to display a list of the item models, we need to use the add directive in order to import a list of these models. To access them, I'm just going to need to write the name of the application, .models, the name of the model. We could also just import this directory on top of the page, but just to write everything in one single line. That's why I'm using it this way. And in this code block here, we usually specify the title of our page, the title of our tab. Basically, we do this with a view data, which is a dictionary in C#. This works with key value pairs, and we can set the value of the title by just writing view data title here as the key, and then we input the value in form of a string, let's say index here for the index view page. If you actually go to the layout page where we specify what will be displayed in the title of our page, you can see here that we can give a value to this view data, to this dictionary, with a key of title, and we automatically give it this text afterwards. We can remove it, we can leave it as it is, so that on top of the page we'll see, let's say, index-my app, the name of the project. And this is how basically view data works. Now back to the index view page. Here we can give a header to our page, like an H3 header named index. And we usually use a table to represent a bunch of data. That's the example I'm using in this case. So like an HTML table element. With a class of table, and we'll separate it into sections. Table head for the head of our table. This is just some HTML syntax. And table body for the body of our table. In the table head, we can use this table row tags to write everything we want to be displayed in the first row, basically this table head. And we can use a table header here by writing th. And here we can input the name and the price of the table, the price of the item. If I just run the project, so that you see what we're doing at this moment. Just click with the right of the mouse here. In the view page you want to be displayed, and then click View in Browser. So here we have specified the table header, only the name and the price of the table, and then the data will come down below in the table body. So in the table body here we can use a for each loop. This will be a C# code, and the Razor pages allow us to use C# conditionals in it by just writing the @ sign and then the for each keyword. Here we'll take a variable and give it a name like item, but it doesn't matter the name of it in model. So this keyword is important. So in a variable we just create a temporary variable here, and we are looping through the model that we are inputting here on top of the page. And down below, inside a single table row, we will display, by using the table data tags, the name of each item by writing the @item, which is the name of the variable we specify here, that name, and another table data for the item that price. And so the price is basically formatted as it should be. We can use this toString method, and inside parentheses the n2. This is just a method that basically displays the price, which is a double with only 2 places after the comma. In the last table, in the last row here, I'm using another table data tag to have 2 links to redirect us to the edit and to the delete page that we'll create later on. So we'll see a table with a list of items, and by having 2 buttons there, 2 links, we'll then be redirected to an edit page for that item, or to a delete page to delete that item. These action methods that I'll redirect you right now will create later on, but just that we have it there. So I'm going to use these anchor tags to redirect us to an edit link, and inside this anchor tag, I'm going to use an tag helper, an ASP action tag helper, and I'm giving it a value of edit. Now, what are tag helpers? Tag helpers are part of the Razor syntax, and they make it possible for us to do specific tasks. In this example, this tag helper will redirect the link to the edit action in our controller. That's the role of this tag helper. There are tag helpers for different things, but basically this is the good thing about the Razor syntax, that it allows us to connect our pages to our server-side code or to our controllers. I'm going to actually use another tag helper to specify the ID of this edit page by using the ASP-route-ID at item.id. So we'll redirect us to the edit page for the specific, with the specific ID for that item. And now we get errors here because we have not created that action yet. Why did I remove it here? Edit. Okay, my mistake there. And here I'm going to use another tag helper, which works the same way, but just will redirect us to the delete page for that specific item. And this is all we'll display in our index page. I'm just going to comment this out for now because we'll get many errors. And just go back to the controller to proceed with the next action. Now, the next action we are going to create will be the action to create an item. Firstly, we just need to create a public IActionResult with the name of create. And this will just return the view, the corresponding view that we're gonna create right now. So just go to the items folder in our views folder and create a new Razor page, an empty Razor page here. I'll name it create. And just as we did in the last time, we need to import the model, not a list of models, but just the model. So the name of our application dot models dot item. And we'll set the title of our page with the view data dictionary here to be create. Let's just input a header saying like create an item. And now here what we're going to do, we're going to use a form to submit the data that we'll input in the form to another action that we're going to create, so that basically we store this new item that we'll create in our database with the help of Entity Framework Core. So I'm using a form first of all here, and I'm going to need to use a tag helper to connect this to an action in our controllers named create, and we need to specify here the method to be post. We are basically going to create a second create action in our controller, which will be of post type. What this means is that this action will be able to get only post requests. So get requests are those requests when the action returns just some data from the server or a web page, and the actions that accept post requests, they are actions that retrieve data from a form submission. And inside this form here, we're going to have some div tags for each of the properties that we'll take in this form. So let me just give a class to this div. This is just a Bootstrap class for some styling, which is named form group, which you can see in the Bootstrap documentation to make the form a bit better looking. And I'm going to set a label for the data that we'll input here. And we'll use this for attribute to connect it to the name of the item, basically. Here inside the label, I'll just name name, which is what will be displayed on the screen, the text. And underneath, we'll write an input tag, which will accept data of type text. We'll give the class of form control to make it a bit visually better. And with the ASP4 tag here, we'll connect this input to the name property of the item, so that when we input this data to our create action, this will know that this data is the name property of an item. And just like we are receiving the name in this div group here, I'll create a new one to have a label for the price here, and to also retrieve a number here in the input, and this will be connected to the price attribute. The last thing we need in the form is a button to submit the data, which will have the type submit. We'll give it a Bootstrap class to look visually better. Button primary, which gives it this blue color, and just name this button submit. And this is how our form should look like. If I run the application and go to actually this page, the form is not yet optional because this page is not yet functional because we haven't created the second action method, but we'll just see how it looks like. Let me see what error I did here. Okay, line 4. Here, I just misplaced the semicolon. Let me run the app again and go to the create page /items/create. This is how our create page looks like. We can input a name here and a price for our item, and if we hit on submit, this data should be inputted to our action method, and then where we will specify how we will store this data as an item in our database. So let's just get back to the code and go to our controller. So here we'll specify a second create action, and since this action will take post requests, we need to specify on top of the page HTTP post for get requests, for actions that receive get requests. This is not necessary to note there, to write there. So I'm going to continue with the method, the action method here, which will also be an asynchronous method. So I'm going to need to write the async keyword. This will return a task of IActionResult. I'll name it create. And here I'm going to need to use an attribute called bind to bind this, what we'll receive in this action, basically the ID, the name, and the price of the data that we input in the form, and to bind it to the item model so that the method recognizes that these data are part of an item. Here we need to write an if clause to basically check if the model inputted in our form is correct. So we're going to use a model state that is valid method. So this method here of the model state class just verifies if the model inputted in our form is an actual item, basically. And if this is the case, we'll use the context that items.add methods. So this method that Entity Framework Course gives us, and add to the context this item. So basically the input from our form, we're adding it to the database in this line right here. We are using the await keyword here, and we'll just use the context one more time to save the changes done to the database by using the save changes async method. And after the changes are saved in the database, we just need to return the viewer to the index page. For this reason, we're going to use the redirect to action that will redirect the user to the index page. Just like we return the view, redirect to action basically is an other result type, just like view result. Redirect to action result is another result type that will redirect the user to the index page, as already mentioned with big I here. And if the model is not valid, we'll just return the user to the current view. So again, to the create page, and we'll input the item here. Let me just run the project and see how our create method, action method, is working. If I put a name for an item, let's say microphone, that price it like $200 or something, just 200, since the price accepts a number, and click submit, should be redirected to the index page. And here we see the name of the item and its price with 2 places after the comma. And basically I can just input a $sign there manually in the index page, in the items folder. So just here, like a $sign. Have to reload the page here. And we should see the $sign after the price. Okay, now let's just go back to our controllers and write another action, which is going to be the edit action. In this case, we're still going to need two edit actions, one for the get request and one for the post request. Firstly, let's start with the action that accepts get requests. This is going to be an asynchronous action or action method, which will return a task of IActionResult. I'll name it edit, and this action will actually receive an ID. Let's open up the curly braces again, and I'm going to use an item variable to loop through the database as a search for a specific item. So basically, when we are redirected to a page with the details of a specific item with a specific ID, we will loop through the database to find that item and display it in the screen. So I'll use the await keyword here to await the result that we expect from the database. So underline context dot items that, and here we'll use the first or default async method that will search for a specific item in the database, where the ID of that item will be equal to the ID that we take here in the action parameters. And then I'm just going to return the view with that, and the view will contain that specific item. Let's just create now another view page for the edit page. I'll name it edit. And what's interesting is that the edit view page will be similar, close to identical with our create page, because it will receive a form that can be changed from the users. Let me just copy what we had from the create page here, put it in the edit view page. The only thing that we're gonna change here is the title of the page, which will be named edit. The header, I'll change it to be edit an item. And I'm going to redirect the users that submit the form to the edit action in our controller. The method is going to be a post method. And as you can see here, basically the user will be redirected to a form with already filled data, to a form to change the name of the price of that specific item. And when a user changes the data here and submits the data of the form, the user will be redirected to the edit action, and we'll need to create the post action in our controller as well. So we need to write the HTTP post data annotation. This will be a public method. It will be asynchronous as well. It will return a task of IActionResult. I'll name it edit. And this action method will receive an ID, which will be int, and also the data from the form. And we'll use this bind attribute here as well to bind the data that will receive the ID, the name, and the price that we'll receive from the form to the specific item model. And again, we need to make this check if the model inputted is a valid model. We need to use the context here and update the database with that specific item. Then we need to use the await keyword here and save the changes to the database with the save changes async method. And then we'll redirect the user to the index page, and we'll use this redirect to action result, and we'll redirect the users to the index page. And if the model is not a correct model, basically we'll return the user to the page they already were together with, and we'll input this item to the page, so that when the user will land on the same place, on the same edit page, the form will be already filled with the data. So let's just run the project here and test this in action. Let me check what I did, what kind of mistake I did there. I think I forgot to close the method here, the action method. Should be okay right now. Okay, let me just refresh the application, and I'm actually gonna go to our index page. The index page in the items folder. And I'm gonna uncomment the edit anchor tag here. So I'm just gonna comment this anchor tag that deletes the items. So I'm just pressing Ctrl K plus C to comment this part. And we should have, in the table, we should have basically a link to redirect us to an edit page for the item that we have already stored in our table. So let's just refresh the page here. Here we have the item's name, the price, and this edit anchor tag, which is basically links us to another page. The address of this link is items/edit/1, which is the ID of this actual item. And here, if I would change the name here, let's say, change it to just like Mike. I can change the price as well. If I hit on submit, we should be redirected to the home page, and the name is changed. The price is changed. So basically, when we submit the form, we call the HTTP post edit action method. Then we basically check if the data submitted is correct. We update the database with that item that is inputted there. We save the changes and we redirect the user to the index page. Now, last but not least, we'll need to create a couple of other action methods to delete the items. The first method will accept GET requests, and it will be a public and asynchronous method, which will return a task IActionResult. I'll name it delete, and this will receive in the parameters here an int ID. I'm using a variable here. I'll name it item, and we'll loop through the database for that item with that specific ID. So I'll use the await here to await the data from the database, and then underline context that items that this first or default async method to search for that specific item. The item's ID that we are looking for should be equal to the ID that we are taking here from the parameter. And let's just return the view with that specific item variable that we have here. Let's just go to our items folder inside our views directory here and create one last view page. I'll name it delete. In this view page, we need to import the item model as well. So by just writing the directory of the models and the name of the specific item of the specific model, we can specify the title of our page here with this view data. We'll name it like just delete. And let's just input a header here asking the user like, are you sure you want to delete this item? Question mark, question mark. And let's just input here in form of a few paragraphs the name of that item that we're receiving in this view page. We'll access the item by writing at and this modal attribute that the view page has, dot name, and I'll use another paragraph to access the price of that model. Let's just write the $sign here as well. And if the user is sure he wants to delete the model, the item that is displayed on the screen, we need to write a form for the user to be able to delete it. So form, to write the ASP action tag helper that we have been using so far to redirect the user to a delete action method that we'll create, which we haven't done yet, which will be of type post. And here we're just going to need an input to take the ID of our model, and because it's not a good practice to basically display on the screen IDs, we just put this input to be of type hidden so that we won't see the input on the screen. And by using the ASP4 tag helper, we'll connect the value in this input with the ID property. And then another input we're going to need to be of type submit. This is just like a submit button, actually. We'll give it a class, a bootstrap class of button and button danger, which makes the button red. And the value, or what will be displayed in this button or in this input, will be delete. Now, when the user clicks on this input time and submits the form, he will be redirected to the delete post action method that we will create right now. Set the data annotation of the method to be HTTP post, and the method will be public. It will be an asynchronous method to return a task of IActionResult. And this method will be good to be named delete as well, but we cannot name it delete because we already have another delete method, which in this case will contains the same parameters. So when we have two action methods that have the same name and the same amount of parameters and the same name of parameters, we cannot have these methods with the same name. For this reason, I'm just going to name it delete confirmed. As a practice, this will receive an int ID parameter, and actually, because we specified in our delete page here in our form, we specified that the form will be submitted to a delete action. The practice, a common practice to be used in this case, is that inside this data annotation here, you can write the action name delete. So whenever user sends a request to a delete action of type post, this method here will receive this request. Now I'm going to need a variable here to get our specific item from the database. I will await the results and we'll get the item from the context by writing context.items, and I'm going to use the find async method. Here we'll input the ID, so we're finding the item we need with this specific ID that we get from a parameter here. And here we need to write an if clause to check if the item is actually not null. So basically, if we can find this specific item with that ID in our database, we want to remove that item from the database using the remove method, which will take the item as an argument here. Next, we just need to save the changes to our database. And as you can see, all of these methods we are accessing by using the context. And then we need to return the user to the index page. So in this case, in this action method here, even when the item is null or not, the user will be redirected to the home page, to the index page. Let me run the project one last time to check all the functionalities of our application. And before I forget, I'm just going to go to the index view page to uncomment the anchor that will redirect us to the delete page. Just hit on Ctrl K plus U to undo the commenting here. The ID here is apparently with a lowercase letter. Let me run again the project. And let's just go to the /items/index page. Okay, here we have our only item here, the mic of a price with price of $300. Just actually going to create a new one, /items/create. Let's say keyboard price 100 euros, $100. Hit on submit. We have our second item here. We already saw the delete the edit option that works. If we click on submit, we'll be redirected to the index page. Let's try the delete, how it works. If I hit on delete here, we'll go to the route items/delete/1, which is the ID of this specific item. And we see here, are you sure you want to delete this item? We see the name of the item, and we should have seen the price here, but apparently something is not right there. Okay, so we need to specify here the model.price. Let's just refresh the page. Okay, we see the mic, the name of the item, the price of the item. If I click on delete, we see that we do not have this item anymore in our index page. So basically we called the action method, the delete action method in our controller. Here we found that item in our database, we removed it, we saved the changes, and redirected the user to the index page. What is a one-to-one relationship? Let's say we have a list of items stored in our database, and we want to connect each item with a single serial number. We also want that serial number to be assigned to only one item. In this case, they need to have a one-to-one relationship. This is what we will learn in this video, and it's going to be super simple. You can see that our item has only one ID, a name, and a price. I'm just going to start by seeing here that our name property in this case has this kind of error. The properties by default are declared as non-nullable, and the compiler basically just wants to remind us that we haven't initialized the value for this property yet. Now, in some cases, we would want to add the question mark after the property type. The error would go away. But in some cases, if we would not want our property to be null, for example, so that we can skip this error, we can just give it an initial value here, like null with the exclamation mark. And basically this gives the name property a temporary null value. So just to remove this warning that the compiler gives us, we give it a temporary value where telling the compiler that we do not want our property to be null, but basically we will take care that we give it a value in the future. I hope that's not complex. And now back to our one-to-one relationship model. I'm gonna need to create a new class in our models folder. I will name this serial number. And let's give it like an ID property. As you can see, the integers and numbers usually don't take an error because by default they can be null actually. But if we'll give the serial number a name as well, and to escape this warning, we'll give it an initial value here. And now we're just going to need these two properties for the serial number alone, but now to connect it to our item with a one-to-one relationship, we're just going to need to connect it with an ID for the ID of the item. I'll write it here, item ID. And also we'll specify here that this will be connected to an item model. And I'm going to need to specify on top of this item property that the foreign key, basically how we will connect this item, this property to the actual item, is that we're going to use the item ID property. So we're using this data annotation to basically connect the item with our serial number using the item ID as a foreign key. And here I'm actually going to use the question mark on top of both of these properties because we want to make it easy for us that we do not have to connect the serial number with an item just as soon as we create this model. We can give it a value later on. We create firstly the model, let's say we create the item, and then afterwards we can connect it to a serial number and vice versa. So I'm just going to go to the models folder one more time. I'm going to go to the item model as well, and I'm going to connect it to the serial number. I'm going to need the serial number ID property and a serial number property named serial number. So basically what we're saying here is that we'll connect this model with a serial number, the item model, and we're going to use the serial number ID as the foreign key basically, but we do not need to specify this data annotation in both of our models. In one of them, it's enough. And I'm going to set this to be nullable as well here, so that, as I also said before, we do not have to specify the serial number ID just as soon as we create a new item model. Now that we have this clarified, let's just go to the context. I'm going to need a dbset instance for our serial number model. Serial number. I'll name it serial numbers in plural. For us to give some initial data to an item and a serial number in our database, we can use here we're going to need to override a method that Entity Framework Core provides us. So I'm just writing here protected override void, since the method won't provide anything, that on model creating. And what this on model creating does here, this is like a method that Entity Framework Core has, which takes a model builder class as a parameter, which is a class that will allow us to configure the different configurations for our models and the relationships with them. So actually by default, there exists an on-model creating class in Entity Framework Core that configures our items, our models, and the relationship between them by default, but now we are overriding it to specify either the data for our models when they are initialized or the relationship between them. So just inside this method here, what we're going to do, I'm going to use the model builder parameter, which was this class that we'll use to add configurations. And I'm going to write that entity. I'm going to write for the item first. So I'm just going to use a method has data here. Just a model has data here to give some data for a model, basically to create a model in our database for the item. How we can do this is I just need to write here new item. And I can, let's say, specify the ID to be like 4. I don't know, it's a number. I don't know if I have an ID with an ID of 1 in my database. The ID is an integer, so no double quotations are needed. The name of our item, I'll set it like a microphone, I don't know, some item. And now I'm gonna add the serial number ID. Do I have a price for the items? I think I do. Okay, I'll set the price to be, I don't know, price to be $40 or something. And the serial number ID, which will be the ID of the serial number, is, I'll input like a number here, like 10, and then I'll need to create a serial number with the ID of 10, so that these two models will be created. Just like I created an item in our database, I'm going to create a serial number as well. So I'm just going to need to write here serial number. We're creating a new serial number. I'll use the ID of 10, so that the first item will be connected to our serial number. I'll name it like, the name was a string, I guess, so I'll name it like Ike, like 150 or something, just some code, that just what could represent a serial number actually. And now I think the only property left is the item ID, which I'll set it equal to 4, so that it will be connected to our first item. After we have created two models in our database, we have the database instances here for the models tables to be created in our database. I'm just going to need to go to Package Manager console and add the migrations. So add migration. I'm just writing here one-to-one so that we know for this migration we edit a one-to-one relationship in our database. You can name it whatever. Hit on enter. Okay, now we just need to update these migrations, this database schema that was created here, to the database. Everything seems to be done correctly. Now, so that we show this on the screen, actually, I'm just going to go to our contacts, to our index page. And when we load the items from our contacts, we need to specify here that we want to access the serial numbers as well. We just gonna need to write an include method after writing contacts.items, after accessing items in our context. And after writing here include, just gonna need to get the variable here and access with it the serial number. Now that we can have access to the serial numbers from our items, we can go to the index page and also display the serial number in a column. So here, like in the table header, just write here serial number, and we'll access it from the database here by just writing item dot serial number dot name of the serial number. We can just run our application now and go to the index page. Let's go here to /index /items, the name of the controller, /index. Now we are getting an error here while processing this in our index page, and the error is actually happening because we have specified this serial number in the item that it could be null. For us to avoid this, we can just give a question mark after accessing the serial number here from the database, and in case it is null, nothing will be displayed in that column. If not, we'll access the name of the serial number. Let me just run the application one more time. And here we should see a microphone priced $40 and the serial number is mic 150. So we have connected a microphone with a one-to-one relationship with a serial number, and actually vice versa as well. And if we would try to, we cannot connect this serial number with another item actually. Even if we would try to do this either in the context or in our database, this would give us an error. And the first item actually here, we haven't connected it to a serial number yet. That's why this column is empty for the moment. Let's say we have a list of items stored in our database and we want each item to belong to a single category. In this case, one category can be assigned to many items, but each item can belong to only one category. This requires a one-to-many relationship between the category and the items. In this video, we'll learn exactly how to set this up, but don't worry, it's not that complicated. We'll connect our models to each other, make the necessary changes in our action methods, and then see how it looks on the front end. So let's get back to the project. And let's go back to the item model as our main model, and we can actually connect this to like a category. And a category is like a one-to-many relationship model with the item, but from the category's side. So a category, let's say electronics, books, or something like that, can have multiple items be part of it, but a specific item can be part only of one category. So how we can write this relationship? Let's just go to the models folder and add a new class. Let's name it category. And I will give it normally an int ID property, a name for the name of the category. And I'll initialize it so that we skip the warning that the compiler gives us. So giving it like an initial value and telling the compiler we'll set a value to this name later. And then we can connect this, we should connect this with a list of items. I'll name it items. And I will make this property to be nullable with the question mark so that when we firstly create a new category, for example, we do not need to connect it with an item right away. We can add this later on. So one category can have multiple items, but if we go back to the items model, one item can have only one category. So I'm going to need a public int ID property, not int ID, but let's say category ID, and a public category named category. Let's specify the foreign key here so that our category will be connected, our item will be connected with the category model by using the category ID property as a foreign key. And I'm going to make both of these properties as nullable so that if we have created a new item, we do not need to specify the category right away. Now that we have specified how this relationship looks in our model classes, I'm going to go to the context and add a dbset instance for us to be able to store this category model in our database as a model instance. So I'll write here category, name it categories in plural as a practice. And I'm going to create manually 2 categories in our database. So I'll use this model builder class as well, that entity that category that has data method. And just write here a new category. Let's say an ID of 1 and the name of, let's say firstly electronics. And I'm just not going to connect this with an item right now. We're going to set it up in our action method so that we can do it, let's say, interactively in our application. And like a new category as well would be okay. I'll give it the ID of 2 and I'll name it, let's say, something else like books. Now I'm just going to add the migration firstly to the database, and then we'll handle our action methods. So just add migration one-to-many. Let's name this migration. And I'm just going to update the database. Okay, the first thing I'm going to do is go to the items controller. Let's start with the index action method. We're going to need to include the categories when we search for the items in our context. So I'm just going to place this a bit below in one line so that we can see everything better. So I'm just going to write this .include method again, give it a variable like C, and just include the category when we search for the items in our database so that this is included as well. But now that we haven't connected actually any of our items with any categories, so we're going to need to set it up in our create page so that you know when you create like an object, you will have an option. Let's say when you create the item, you'll have the option to select one of the default categories. For this reason, we are going to need to display all of the categories that we have in our database in the create page. How we can do this? We're going to use the view data dictionary that we can use in ASP.NET Core. I'll name it here. We'll give it a name here of like categories. And here we'll give a select list to this view data. What this select list will contain, we'll loop through the context to get the categories, and we'll search them by the ID. And we'll basically say here that we'll display them by their names. So we'll get the ID and the name of these categories from looping it through the database. And this list that will be created here, will give it into our view data dictionary. We're going to need to write this using directive on top of our page. This using Microsoft.ASP.NET Core.MVC.rendering, which basically is the directory that includes this class, the class for our select list. And now we basically have a view data dictionary passed to our create page that we can use in our create view page. Let's go to our create view page here. And how we will access this, I'm going to need another div here, a form here for the user to be able to input a category when they create the items. So the label will be for the category ID. Let's say category here as the label for this form. And actually we are gonna need to use here like a select HTML tag. Here we need to specify this tag helper ASP4 to connect this to the category ID property. And in the ASP item, in the ASP items tag helper here, we're gonna need to include basically what we take from our view data dictionary. We can do this by writing viewBag.categories, which was the name of our view data, and the viewBag is actually the class, just like a dictionary that we use to take this data that we have from our controller and display it here on the view pages. So this is as well another class, and I'm just going to give a class to our select list here of form control. And this is it with the view page. What we should write in our view page. If we go back to the controller, now if we go to the post action method, we need to bind here the category ID that we'll take from that select list as well. And we could leave it as it is now, but we can do the same thing and modify the edit page as well, so that for the items where we haven't specified the category, we can edit them later. So I'm going to need this view data dictionary here to input in the edit method, in the edit action method. In the post method, we can include then the category ID, just the same way we did with our create method. And we are going to need to modify the edit view page by just giving it this line, this div group here for the list that we had from the create page. Let's input it in the edit view page. Just the same thing. So we're inputting like a form for us to modify the category as well. And if I run the application, let's just see how we can create an item with a category from the list of categories we have in our database, and how we can edit it for maybe the items where we didn't input a category. So if I just refresh here, let's go to the create page. Okay, so we have probably made like a typing mistake somewhere. This select text, I forgot an E. Select here as well. And let's just update it in the edit page as well. Okay, let me run the application one more time. Here we see in the category input here, we have a list of both of the categories that we have written in our database. So we can select either electronics or books. Since we have a books category, let me write the name for a book. Let's say tech book, like C# book. Let me give a price to it, like $20. The category is books. Let me submit it. We should be redirected to the index page. A C# book was created here. We had the price. We didn't give it a serial number, but we forgot to write a column for the categories actually. So let me go back to the project, to the index view page. Okay, just another column header here for the category. And down below as well to get the value of the category for each item. So item dot category dot name. We can input the question mark here. If it's null, we'll display it. We'll display nothing. Let me run the application one last time. At least I hope one last time. Okay, so we see here in the category column here, we see that for the item that we created, we see the books, the category. Now, since we changed the edit action method and the edit view page, we can basically edit these two other items to have a category as well. So if I go back to the first item and click on edit, we can input a category to the first item, click submit. And the keyboard now has an electronics category. Let's go to the microphone item. I'll leave it as electronics as well. Click on submit. So we changed the category for these two items as well. So the electronics category is connected to two items in this case. Let's say we have clients and items in our database. Each client can have multiple items, and each item can be bought by multiple clients. This creates a many-to-many relationship that we need to manage with a helper model. In this video, we'll cover how to set up the models, configure the relationships in the database, and make the necessary adjustments in our application. So let's just go back to our project, and our main model was the item model. Now, if we connect the item with a client model, let's say one item can be purchased by multiple clients, and one client may purchase multiple items as well. So this is a many-to-many relationship between the item and the client. Unlike the other relationships we've seen before, this type of relationship requires an additional helper model to connect these two models with one another, which we'll see in a bit. But firstly, let's just create a client model by just going to the models folder and adding a class for the client. And firstly, we'll just give it a public int ID property and a string name property. We'll initialize this property here to avoid the compiler warnings. And now, as I already said, we're going to need a helper model. So this client model will be firstly connected to this helper model in order then to be connected to the item model. We'll see this better after we create this helper model, which usually takes the name, takes a combination of the names of the two original models. We can name this item client. And this model will be connected to both the client and to the item. For this reason, we are going to need firstly a public int item ID property to connect to the item, and of course an item property named item. So basically, using the item ID, this item client model will be connected to an item model. And the same thing will happen also for the client model. So we need a client ID property. And a client property named client. So that basically what we're telling the item client here is that the item client model will be connected to the item and to the client using these foreign keys respectively. So the item ID for the item and the client ID for the client model. And in each of the other two models, we need to connect these two models with this helper model. And basically we need to have here a list property, a list of item clients, to connect our model with multiple item clients. I'll name it item clients as well. And I'll make this property nullable so that we do not have to assign a client firstly as soon as we create the item or as soon as we can create the client of that. And I'm going to copy this property and paste it in our client model as well. So basically the client here and the item as well are firstly connected with the item client, which then connects them to the specific item in this case, for example, in the case of the client. And now what we need to do is go to our context class and actually add these dbset instances of the two new models we created so that they will be stored as tables in our database. So public dbset client, I'll name it client, and also a dbset instance for our helper model. Named item clients. And unlike the other relationships, actually, we are going to need to specify this relationship of the item and the clients with the item clients model in our context as well. So just somewhere inside this onModel creating method, we'll basically firstly use the model builder class to specify the relationship of the item client model or entity with the item and the client. Basically here we'll firstly specify the foreign keys that are in this model. So item client we need to write here. that has key. So here we specify both of the foreign keys. Let's take a variable here, item client. We need to write the new keyword, and inside curly braces, then here we will specify the two foreign keys. So the item ID and the client ID. And in another line, then we will basically specify the relationship that this item client model has with each of the two models. So here we specified the keys. Firstly, the foreign keys. Here we'll specify the relationship in a bit more detail. So we need to use the model builder class again. Dot entity item client. So we basically say here that the item client entity is connected to the item model first. Item model, and we write the with many method that specifies that an item can be connected to multiple item clients model. And we specify the foreign key again, which will be the item ID. And we'll copy, I'm just going to copy this line and do the same thing for the second relationship between the item client and the client model. So we just need to change here the relationship so it's connected to a client model with multiple, which is connected with multiple item clients, and the foreign key here will be the client ID. And that was it for our configurations in our DB context about the relationship between our three models. Now let's go to Package Manager console. Let me make this bigger and add another migration for the many-to-many relationship. I'll name it just many-to-many, the name of the migration. And the database schema or the migration was created. Now let's just update the database. So all of the changes we made in our project will be reflected in our database as well. Everything was built successfully. So now for this video, I'm going to go and see the database, and we're going to populate the data in the database. So I'm just going to go to the database that I connected with this application. Let me refresh it. If we go to tables. Okay, I'm just firstly going to go to the items table and click on edit top 200 rows so that we see the top 200 rows. Okay, let me just see the clients table, edit top 200 rows as well, and the item clients model. Okay, so what I'm gonna do here, let me just firstly create two clients, one with a name, let's say Zach, and one with the name like Martin. So we have two clients with the ID of 1 and 2. Let me just find our items here. So our items, we have an item with the ID of 2, one with the ID of 4, and one with the ID of 102, 1002 actually. So I'm gonna connect in the item clients table here. I'm gonna connect the item with the ID of, I think, 2 with Zach here, which was a client with ID of 1, and the item with the ID of 4 with Martin, and the other item had the ID of 1002, and I'll connect it with Zach as well. So Zach here has purchased 2 items, so to say. Okay, now that we have set up some data in our database, let's go to the project. I'm going to need to go to the index action method in our controller, actually, so that we include here when we query the items in our database, we want it to basically include also the list of clients with which an item is connected to. So here I'm going to add a new line and click on include. I see that item clients. And then in this case, in a many-to-many relationship model, we need then the then include method. So basically, after we include here the item client helper model, with which the item is connected, then we need to include with this then include method the client's model, because the item firstly is connected to the helper model, to the item client's model, and then it is connected to the client's model. I hope that's not too complicated. To the client. Okay, now I'm just going to need to go to the index page, to the index view page, and add a new table header here for the clients. And down below, where we display the list of clients with which a model is connected to, I'm just going to use this table data tag here, and I'm actually going to use a for each loop, because one item may have multiple clients. Here we'll loop through a variable. I'll name it client in item clients, which is here. This was the temporary variable we created, and we'll loop through each item's item clients. Then we'll display the clients name. So we are accessing for each item the item client's helper model, and then the client.name property of that model. Let me just run the application. Let's refresh the items route. We should see another column in our table, and we see for each item, we see the client. So for the keyboard, we see that the client is Zach, for the microphone is Martin, and for the book is Zach again. So basically, in this case, each item has only one client, but the client has two items. And this is basically how the many-to-many relationship works in ASP.NET Core MVC. If this video was helpful, YouTube thinks you should watch the video that's now appearing on the screen, so I'll see you there. Don't forget to hit the like and subscribe buttons for more content like this, and I'll see you soon.